Recursion is basically describing something with itself. So, what do we mean by that? So, a real world example would be describing who your ancestors are. So, your ancestors are your parents and their ancestors. So, we use ancestors to define ancestors. So, if you keep going, now for your parents, their ancestors are their parents' ancestors. So basically, the ancestors to your parents are the ancestors of all your grandparents. So this is how this is a recursive definition that's found in real life. Now, recursion is a very useful tool in problems that you can divide into smaller subproblems. So one of the most common example would be the factorial. So if you want to find the factorial of n, you can simply find it by using the factorial of n minus 1. So n factorial, if you want to find it, is simply n times n minus 1 factorial. So basically you're using a factorial to define what a factorial is. Now if I wanted to write a function that returns a factorial for me, I can do something like this. So I use the factorial function inside to describe the factorial function. But the issue with this is it needs to end somewhere. So even for this, this has to end when your ancestor, when you reach the first human, or if you believe in Darwinian evolution, the first person that became a human. So it ends there. So you need the base case. The base case here is the first human. You cannot go to the parents of the first human. Like in this case, the parent or the base case for factorial would be when n is 0. So 0 factorial is 1. You cannot have minus 1 factorial. So this is the so this is like the first human case over here. So in the ancestor case, the first human is the base case. For the factorial, the 0 factorial is the base case. So if n is 0, you return 1. Other than that, you return n multiplied by the factorial of n minus 1. So you're basically describing a factorial using a factorial of a smaller problem. And the best trick to use while you're using recursion is not to break this down further than this. So if I'm approaching a factorial problem, the way I'll approach this is thinking it's n times n minus 1 factorial. I will not break this n minus 1 factorial down into anything. The biggest mistake a beginner can make is thinking like this. So I'll see n factorial, I see n times n minus 1 factorial. I might go and try to break this down into n minus 1 times n minus 2 factorial and think like that. But this is a huge mistake. You need to think of this as it is. You don't have to go and break this down further than this. And this part isn't necessary to understand, but I'll show you another example of a thing that you can do recursively. So basically n choose r. So basically if I want to have a function n choose r, it will take in two inputs. The inputs are n and r. Now if I want if I think recursively, n choose r is gonna be n minus 1 choose r. So basically I did not choose the first element, and then I did if I had, so I have 4 elements and I'll choose 3s or I'll choose 1s. I can either choose to pick the first element or not. So if I do not choose the first element, I still have to choose R elements. So basically this is 1. I haven't chosen the first element, so this doesn't decrease. But now I have eliminated the first one and I have 3 more left. So I have n minus 1 elements left. And this is the recursive case. So this is just n minus 1 choose R. The other case is I choose the first element. So I'll choose this element. So if I choose this, now that's eliminated as well. I'm left with n minus 1 elements. And now since I've chosen 1, my R will also decrease by 1 because I've already chosen one of them. So this will be R minus 1. So if I want to implement a function like this, you can see how you can define n choose R using the choose function. So if I have a function choose takes in n and R, I can just return choose of n minus 1 R plus choose of n minus 1 R minus 1. And now we have to think about the base cases. The base case, one of the base cases is if I have to choose nothing. So if R is 0, there's exactly one way of choosing nothing, and that's to not choose anything. I mean, it's a vague description, but there is only one way you can choose nothing. So that's the gist. So one of the base case, so base case 1 is if R is 0, then you return 1. And the other base case is if R and n are the same. So if n and R are the same, so basically if I have to choose 4 things from 4 things, there's only one way to do it, and that's to choose everything. The other base case, so base case if n is equal to R, then you return 1. So if I organize it into a better form, so this is how the function would look. The first one is one of our base case, the second one is the other base case, and the last statement is the usage of recursion. And if you want to visualize this, you can also look at the Pascal's triangle. So this over here, you don't need all of this. I'm just showing you an example of recursion. So these are the values of so this is level 1. So this is 2C0, this is 2C1, 2C2. So 2C1 is 2, this is 3C0, 3C1. So if you look at 3C1, it's basically adding these two together, which are 2C0 and 2C1. See, this n becomes n minus 1, n minus 1, and this R becomes R minus 1 and R. So this is basically n C R equal to n minus 1 C R minus 1 plus n minus 1 C R. This is another way you could see the recursion in this case. And that's it for recursion. And before I leave, a good way to think about recursion would be to try and think that you already have a solution to a smaller subcase. I've already mentioned this before, but I'll stress over it again. Do not break this down into its components further. It might make it way too complex for you to think about. So just leave it as simple as you can. And that's it for this video.